Hello everyone, this is Patrick Arnold, analyst at ARC, talking to you from the ARC Forum in Orlando. I'm sitting here with Erik Nordmark, CTO and co-founder of ZEDEDA. Erik, could you just tell us a little bit about yourself and your history?
Sure. So I've been around in the technology industry, building technology for a long time, sort of learning about operating systems, virtualization, hypervisors, networking, been involved in internet standardization. I sometimes say that, if there's something you don't like about IP version 6, you can at least blame some of that on me. But and then getting involved with this gradually over time by various leadership roles and understanding what was first going on with sort of IoT and then industrial IoT, and then seeing what value can we actually bring from the rest of the software stack into this environment. So that's sort of how we started ZEDEDA and said, hey, let's go try to improve things here. So.
Mm-hmm. Okay, so there's obviously a lot of excitement and curiosity about what AI can do for industry. And could you speak a little bit about how your approach to maybe AI on the industrial edge?
Yes.
From ZEDEDA's point of view?
So yeah, I think we already have customers that are running with sort of ML, the sort of more classical AI, right, out in the field with GPUs, et cetera, right? So that's something that we've already enabled. This area is accelerating a lot because both from the perspective of people getting more attention around this stuff, the application of LLMs, basically enabling people to solve problems like bringing staff up to speed and making it more accessible, the sort of internal documentation and other things they have, even out in the field. Like if you're out on an oil field, can you actually get access to that thing? Can you get responses, et cetera, out of the system without having to go through manuals and other things, right? So that's new. But the other thing that's happening is people are, because of the cost dropping for this, the ability to do more things using video analytics, et cetera, that is actually expanding a lot. Both the cost of the hardware dropping as well as the models improving a lot, and people figuring out how they can actually create models that are targeting the edge by doing quantization, et cetera, to make them be smaller, to make them fit, right? So the sort of cost factor for this running infinite inference at the edge, it's not like you don't necessarily need very powerful compute out there to do this. Very different than the training and the extremely large LLMs going on in other parts of the AI ecosystem, right? So people shouldn't be distracted by that instead of looking at what can actually be done out at the edge with what budget, what resources, et cetera. So.
Yeah, that sounds really exciting. Could you just maybe talk a little bit about some of the key use cases for AI at the edge, predictive analytics or things of that nature?
Yeah, so people are doing predictive maintenance, right? Being able to extract more value out of the data that they already have, and this is relatively easy and to add on to an existing system, right? You're not touching any of the control loops; you're just adding things there. They also are doing things like process optimization. Again, sort of not touching the actual control part of it, but figuring out, okay, can we build something on top that can actually learn and adjust based on whatever mixing, whatever things that actually make the product be better or be more cost effective, right? So, and then there's other applications like video analytics for safety, right? These sort of classical, is everybody wearing a hard hat on the site? So these are things that are within reach, possible to deploy today, right? And then I think that the application into other domains will actually increase as people realize that as people figure out how to do the models that actually fit, right? That, okay, we can actually run this stuff on a regular computer, maybe without a GPU, right? Or on some small compute out there that's not expensive, like an NVIDIA Jetson. And then people will come up with new domains that they will apply this stuff into. So.
Yeah, you talked about sort of moving AI inference to the edge. Could you speak a little bit about maybe the shifting dynamic between the edge and cloud when it comes to these new technologies?
I think that just like what we've seen with other data is that originally when people connected the edge to the cloud, they would just ship all of the data to the cloud, right? And then they realized that, okay, this is not necessarily very efficient because they have to pay for bandwidth. As well as they couldn't actually have anything that reacted to that data locally on site if the internet connection was down, et cetera. So people have built up things, sort of the classical compute. One of the motivations for that is being able to do this getting data compression as well as having the data, the results available locally. And we see the same thing with AI, right? Yes, there's some things you can do by just having an interface to the cloud, but that means that if your plant is disconnected from the cloud, okay, now you don't have access to that functionality. So that's one of the drivers of this, that people actually run the inference at the edge.
So how do you see ZEDEDA's role in, when people are looking to utilize these technologies like, say, AI or analytics? They need to develop a comprehensive data strategy to make sure that they can fuel all these use cases. How do you see ZEDEDA's role in helping people with that?
So, I mean, fundamentally, we might be viewed as sort of being the boring infrastructure, right? But what is actually key for this, because in many cases you have some cybersecurity requirements and other things in terms of the robustness of the platform, so that it's actually key that you have a good foundation to build this stuff on. And if you're testing things out in the lab with your AI and your models or your analytics, you might not worry about those pieces. But when you actually go to saying, okay, I'm going to deploy this at 100 sites, 1,000 sites, 10,000 sites, what do I actually need to make sure that if there's anything that goes wrong, I can recover from it without necessitating a truck roll? And if there's something that happens to these things, what do I know about the security of that? Like for instance, if you have 1,000 devices out there, likely one of them or more is going to get lost. Were they stolen, but they disappeared? So what data was on that? Was it your applications? Was it the data it was gathering, right? That is now potentially at risk from being disclosed. So what we're providing is that foundation of saying you can now actually first have the whole operating system update, patching, updating of your applications, deploying new applications and new models, so that if you want to sort of upsell new things into this space, the fact that you have some compute out at the edge, and you want to upsell by bringing in additional applications, you can actually easily do that with a click of a button, and also operate that stuff across very large scale deployments. So that's the key sort of base value of ZEDEDA. And then as we're getting into more of the AI and the models, it's actually clear that the rate of change will actually be a lot higher. People will be able to update models quite quickly, and they're going to do that, especially initially. They're going to retrain them, etc. So the need for doing this is actually going to accelerate. But at the same time, people need to keep track of what they have, right? To sort of like, it's not just about the hardware inventory, it's which version of my model am I running where? Or which version of my container, my application am I running where? That's actually key data, and then being able to drive that. So this sort of rate of change, the potential for rate of change here and sort of diversity, creating snowflakes out there in the field, that's actually one of the challenges that we actually address directly, both for existing sort of compute as well as the evolving AI landscape. So.
Okay, so software containerization and Kubernetes might be new to some people in the OT realm.
Yeah.
Could you talk about how ZEDEDA views that topic?
Well, yeah, no, I mean, we've been on a journey as a company as well, because when we started, it was like, you can deploy virtual machines. You could take your application on Windows and you go run it on our platform. But then the new things have been developed either for the edge or being developed in the cloud, and you want to run part of that out at the edge as containers, right? Basically, cloud native development. Sure, the deployment timelines are different at the edge. You want to make sure you test it for a bit longer than if you're just running the website in the cloud, right? But the same principles that enabling this stuff is actually there. And then how large are these deployments? What's sort of the complexity of the software stack? People can do this differently, but in many cases, we see that, like picking AI as an example, you're likely to get a container that has the inference engine with a model as one thing. But then you want to hook that up to your business logic. So what do you do with the answer that comes out of the AI? Maybe that goes to an HMI system where the user can actually see the results. Maybe it's something that feeds into the process to sort of tune the process, right? So that business logic is going to be a separate container. So it's key to get used to this notion that, yeah, we're going to have multiple containers in these applications across the board. And then now you have the flexibility of not changing this. And in the future, we also see that you might have mixed criticality workloads. This has sort of hardware, software, the whole stack implications, but being able to run soft PLC type things on the same hardware, assuming it's capable, together with these other pieces. And the rate of changes are going to be very different. You're not going to change that soft PLC, maybe never, right? Or maybe every 10 years. But other software like the model, you might change that every month, right? So having a platform where you can actually deal with the different ranges of things is actually key. So, and that is sort of like not thinking of things as monoliths, right? Thinking of things as these bite-sized chunks with containers. That's the key thing. Kubernetes is a very flexible way of then orchestrating when you have large sets of containers, and as well as being able to deliver high availability at the edge. So we've developed things where you can actually leverage Kubernetes technology so that without getting into needing to be an expert in Kubernetes, but you can actually leverage this technology to be able to do failover between different nodes. So if one of your compute nodes crashes, whatever, right, power goes out, the power supply fails or whatever, well, you have two other ones sitting next to it, so you can actually do this failover automatic without needing to be a Kubernetes expert. Right? That is actually key. So.
All right, well, thanks so much for talking to me, Erik. This has been Patrick Arnold, analyst at ARC at the ARC Forum, sitting down with Erik Nordmark from ZEDEDA. Thanks so much for watching, and we'll see you next time.